Students, how was the last class? I hope it was good. So now we are moving on to the next topic, which says electrophoresis. Electrophoresis. Now, electrophoresis is the movement of charged particles. Movement of charged particles such as molecules or ions through an electrolyte under the influence of an electric current. Take note. It is the movement of charged particles such as molecules or ions through an electrolyte under the influence of an electric current. Now, the electric field is applied to a solution. No, there is a source of current. The electric field is applied to a solution by placing, there are two charges. There are two oppositely charged electrodes in the solution. Now, depending on the nature of charges, now the molecules move. They move through the solution towards the electrode of the opposite charge. Now, what do we mean? The positively charged particles, which are the cations, they move towards the negatively charged electrode known as the cathode. Take note. Known as the cathode. And the negatively charged particles, which are known as the anions, they move towards the positively charged electrode known as the anode. At a fixed pH, the rate of migration of particles with similar charge will depend on the magnitude of charges carried on them and molecular weight or charge/size ratio. What are we saying? We have in electrophoresis, you can't talk about electrophoresis without talking about charges. You have the positively charged ions, you have the negatively charged ions, and you have the positive electrode, you have the negative electrode. So the positive charged ions will move towards what? They will move towards the negative electrode, while the negatively charged ions will move towards what? The positive electrode. So that is how it is in electrophoresis. And at the end of this, separation will take place. So I'm not going to bore us too much about electrophoresis. I want us to look at other methods that are used for chemical assays. The first one I have here is the spectroscopy. Spectroscopy, a part of white light passing through certain color solutions, is absorbed in relatively narrow areas of the spectrum. Relatively narrowed areas of the spectrum, which is the visible range. Now, giving dark regions known as absorption bands. Known as absorption bands. The position of these bands can be used to identify the colored material in solution. The position of these bands can be used to identify the colored material in solution. A vision spectroscope is used to observe these absorption bands. A vision spectroscope is used to observe these absorption bands. The second one we are going to be looking at is flame photometer. Flame, also known as flame emission spectroscopy. This is also known as flame photometry or flame spectrometry. When some elements are heated directly in a flame, their atoms become excited and they emit energy at a wavelength that is characteristic of the element. Now, the intensity of the flame color is directly proportional to the concentration of atoms in the sample. For example, elements which are on ground state, and by the time they are heated up, if you have seen a flame photometer before, you see lights. So when these samples are heated up, what happens? They will now move from their ground state to a higher energy level, and at that point they emit excess energy. Now, this excess energy that they emit is what is being measured. And here we said the intensity of the flame color. Now, the flame color is directly proportional to the concentration of atoms in the sample. Flame photometry is commonly used for elements such as sodium. Sodium gives a yellow flame. Potassium gives a red-violet flame. And lithium gives a red flame. The flame intensity can be measured in a flame photometer using appropriate filters. The flame intensity can be measured in a flame photometer using appropriate filters. The next one we're moving to is potentiometry. Potentiometry tries to compare the potential difference between two electrodes which are immersed in a solution under zero current conditions. Take note. Now, by using a reference electrode of known potential, the charge on the other indicator electrode can be determined. There is a reference electrode, then there's another electrode, which is indicator electrode. By using a reference electrode now of which you know the potential already of known potential, the charge on the other indicator electrode can be what? Determined. It is most commonly used. The most commonly used reference electrodes are the saturated calomel, the saturated calomel electrode, and the silver chloride electrode. We look at the next one called coulometry. You know, when you hear coulometry, it looks as if it's colorimetry. No, they are two different things. Coulometry measures the current passing between two electrodes. When constant current is applied to generate a titrating agent, the time required to titrate the sample is related to the amount of analyte in the sample. And remember, I said it measures the current that is passing through what? Passing between two electrodes. While colorimeter is talking about absorption and concentration. Okay, so we'll be looking at ion-selective electrode briefly. If a metal rod is placed in one of its slots, it requires an electric potential. If two different metals are immersed separately into their own slots, the difference in their potential can be measured. Now, by using a standard electrode. By using a standard electrode, the potential of all other electrodes can be measured. So I think we will stop at that. When we come in our next class, we'll be discussing about turbidimetry and nephelometry. So see you in my next class. Bye.